Question 1. So we've got to show this. So take the left hand side, just work through and make sure that you end up getting the right hand side. So first things first, I've gone and changed both these numbers on the left hand side into a improper fraction, a top heavy fraction. So 1 2/3 is 5/3, because the whole is 3/3 plus the other 2 is 5/3, and 2 3/4 is 11/4. 2 4s are 8, add on the 3 to get the 11. So the next step is to get a common denominator. So 3 and 4 both go into 12. So I'm going to change each of these fractions into being out of 12. So for this first one, I've got to choose to multiply top and bottom by 4. 5 4s are 20, 3 4s are 12. And for the second fraction, I need to multiply top and bottom by 3. 11 3s are 33, 4 3s are 12. So I've now got my common denominator. I then add my numerators. 20 add 33 is 53. So, and then finally I convert this improper fraction back into a mixed number. 12 4s are 48 with 5 bits remaining. So that's 4 5/12 as required. Question 2. So we've got 60 children in a club and we've got to split them between girls to boys 3 to 1. Now a ratio of 3 to 1, that's 4 shares in total. So 60 divided by 4 shares means 15 children per share. Well, we've got 3 shares for the girls, so 3 lots of 15 is 45 girls. 1 share for the boys, 1 lot of 15 is 15. So we split our 60 children into 45 girls and 15 boys. So that's a 3 to 1 split. Now with these girls, we're told that 3/5 of them play a musical instrument. So to work out 3/5 of 45, we can just simply pop that into our calculator using the fraction button 3 down on the left hand side. 3/5 of 45 is 3/5 times 45, which is 27. And 4/5 of 15, because 4/5 of the boys play a musical instrument, we do 4/5 times 15 to get 12. So these are the girls playing instruments, these are the boys playing instruments, so that's 39 children in total playing instruments. We've got to give our answer as a fraction, so it's 39 out of 60. Now that's fine as a final answer because we weren't asked to simplify it, but if you do simplify it by dividing top and bottom by 3, you get 13 over 20. Question 3. So we've got to work out the length of PQ here. Now in order to do that, we're going to need to know the length of the other two sides. Well, we know this length is 5, but we don't know what QS is yet. So as an opening step, we're going to work out the length of QS, but by looking at this triangle on the right hand side, QSR. So we've got side, find a side, so that's going to be Pythagoras. And as we're working out one of the shorter sides, it's going to be a subtracting Pythagoras. So we can say that QS squared equals 14 squared, take away 10 squared, which is 96. So QS squared is 96. So now moving over to this triangle on the left, PQS, we want to work out the length of PQ. So it's now side, find a side. We know the length of PS is 5. We know that QS squared is 96, or QS is the square root of 96 if you like. So to work out the length of PQ, it's another Pythagoras, but as we're now working out the hypotenuse, this is going to be an adding Pythagoras. So PQ squared equals 5 squared plus QS squared, which is 96. 5 squared plus 96 is 121. So PQ squared equals 121. So PQ is the square root of 121. And using our calculator, we get 11. Question 4. Now we're told the range of the 4 numbers is 14. Now the range is the biggest number, 40, take away the smallest number, a. So 40 take away a equals 14. So we can then just, from that, we can just add a to both sides, take away 14, and work out that a must be 26. Now we're also told that the median of the four numbers is 30. Now the median is the middle one. Now as we've got an even number of numbers, we've got two numbers in the middle, the a and the b here. Now how do we work out the median when we've got two numbers in the middle? Well, we work out the midpoint between these two numbers. Now to work out the midpoint, you add them together and halve it. So we know that a plus b divided by 2 has got to equal the median of 30. So a plus b over 2 equals 30. Multiply both sides by 2. We get a plus b equaling 60. Now I've already worked out that a is 26. So 26 plus b equals 60. So b is 60, take away 26, which is 34. Question 5. Well, we're being asked to work out the average speed of the train in kilometres per hour. Well, we know the kilometres, but we don't know the hours. We just know that it's 8 minutes. Now, to convert 8 minutes into hours, we need to just divide by 60, because there are 60 minutes in an hour. So 8 minutes is 8/60ths of an hour. 8 divided by 60 simplifies to 2 over 15. Now to work out the speed, the average speed is the distance divided by the time. So it's 30.5 divided by 2 over 15. Just pop this into your calculator and you get 228.75 kilometers per hour. Question 6. Well, the key bit here is to appreciate that this is an isosceles triangle, and we know that because of these two dashes here indicating that those two lengths are the same. Now, what do we know about an isosceles triangle? We know that the base angles are equal. So 3x plus 10 has got to equal x plus 52. So we've created an equation. Now to solve this, we just take away x from both sides and take away 10 from both sides, giving us 2x equaling 42, divide by 2 and we get x equaling 21. So we can then just substitute this 21 back into either here or here to work out the size of the base angles, which is 73. So both of these are 73. Now the angles in a triangle add up to 180, so to work out y, we're going to do 180, take away 2 lots of 73, which is 34 degrees. Question 7. So these two towers are proportional. We're told that the height of tower A on the model is 90 centimeters. So how high will be tower B in the model? So this is a proportion we've got to use. Now we need to make it smaller, so it's going to be 147 over 187. So we take our 90 centimeters and multiply it by 147 over 187, giving us 70.748 ... which to the nearest centimetre is 71 centimetres. Question 8. So I need to either line up my x's or line up my y's. Now if I was going to line up my x's, I would take equation 2 and multiply it by 4 to give me the 4x, but I'm actually going to line up my y's. So I'm going to take my equation number 1, and in order to turn my 2y into a 4y, I'm going to double it. So I'm going to double all the terms in equation 1. So 8x plus 4y equals 18, doubled all 3, and then I compare that to my equation 2, which I've done down here. Now I've lined up my y's, but because the signs are different, in order to eliminate these y's, I'm going to choose to add the two equations together. So 8x plus x is 9x, 4y added together was minus 4y is nothing, that's the whole point, and 18 add 9 is 27. So 9x equals 27, divide both sides by 9 and I get x equaling 3. Now to work out y, I now need to take this 3 and substitute it back into either of the two opening equations. So I've chosen to use the top one. So 4x plus 2y equals 9, but I've just worked out that x is 3, so 4 times 3 is 12. So 12 plus 2y is 9. Subtract 12 from both sides, I get 2y equaling minus 3. Halve both sides, I get y being minus 3 over 2, which is minus 1.5. Question 9. Now, with a standard form number, the first number has got to be between 1 and 10. So where would we put the decimal point in 480 to get a number between 1 and 10? Well, it would be between the 4 and the 8 to give us 4.8. Now, how do we convert 480 into 4.8? Well, we divide by 100. We divide by 10 squared. Now, we can't change the number overall, so to offset this, we're going to do the opposite. We're going to multiply this by 10 squared. Now, when we multiply, we add the powers. 9 add 2 equals 11. So 4.8 times 10 to the 11. Part B, write n as a product of powers of its prime factors. So we've got 480 times 10 to the power of 9. So start off by finding the product of powers of the 10 to the power of 9. This is going to be 2 times 5 being 10, so that's 2 to the power of 9 times 5 to the power of 9. So we're then just going to have to break down the 480. So I've done our usual number tree work to break that down. And the product of prime factors of 480 is 2 to the power of 5 times 3 times 5. So I've brought that over here. 2 to the power of 5 times 3 times 5 being the 480. And then we've still got the 2 to the power of 9 and 5 to the power of 9. So then just gathering up like terms, I've now got 2 to the power of 14 times 3 and then times 5 to the power of 10. Now for part C, I've got to find the largest factor of n that is an odd number. Okay, so let's consider each of these terms in turn. Now 2 to the power of 14 is even. Obviously 3 is odd and 5 to the power of 10 is odd. Now to get an odd number, I need to multiply an odd by an odd. So to get the biggest odd number I can get, I'm going to multiply this 3 by the 5 to the power of 10. So basically the biggest odds I can get from here and here. So my largest factor, which is odd, is going to be 3 multiplied by 10 to the power of 5, which is 292,968,75. Question 10. So I need to work out the area of this shaded area. So consider the full half circle as if it was all completely filled in. So that would be, how do you work out the area of a semicircle, which was the whole shape? Well, a normal circle is pi r squared, so as it's a semicircle, it's going to be half pi r squared. So half times pi, and then the radius of the whole circle, a semicircle, if it was filled in, would be 6. So half times pi times 6 squared, which is 18 pi. Now I then want to subtract from that this area here, this bit that's been cut out. So again it's going to be half pi r squared. Now my radius of this inner circle is 4. Okay, so how have we got the 4? Well, we know the length all the way across is 12. This bit is 2 from here. This is 2. So this length here must be 8. So the diameter of the inner circle is 8. So the radius would be 4. So half times pi times 4 squared, which is 8 pi. So the area of my shaded bit is going to be 18 pi, subtract from this 8 pi, giving me 10 pi. And that's my final answer, because I've been asked to give my answer as a multiple of pi. Question 11. Well, I'm told that the mean number of coins that the boys have is 5.5. So when you add up the total number of coins that the boys have got, divide it by the 12 boys, you get 5.5. So working backwards, what must the number of coins add up to? It must be 12 lots of 5.5, which is 66. So let's just run through that again. 66 coins for the boys divided by across the 12 boys, so divided by 12 gives me an average of 5.5. So working the other way, 12 lots of 5.5 is my 66. So we've got 66 boy coins, and the number of coins that the girls have, we're told, is 18. So the total number of coins is 66 add 18, which is 84. So what's the mean number of coins across the 20 children? Well, we take our total number of coins of 84, divide that by the 20 children to get 4.2 coins. Question 12, part A. So this is a bit different, this one. I hadn't seen one like this before. So we've got a sequence of fractions, but then we've got both the numerator and the denominator have got their own arithmetic sequences. So we can see that the numerator, compared to its position 1, 2, 3, 4, the numerator is just the position. So our numerator is just n. Now with regard to the denominator, this is just our usual arithmetic sequence type of question where we've got to work out the nth term. Well, we can see we're going up in 2's, so it's going to be 2n. And then the adjustment we do is this 0th term, the term that would be at the front of the actual first term. So working right to left, we can see we're going down by 2. 1 take away 2 is -1. So the 0th term would be -1. So our nth term expression for the denominator is 2n minus 1. So our overall answer is n over 2n minus 1. For part B, so if we double any number, we get an even number. So let's let 2n equal any even number. And then if we add 1 to an even number, it becomes odd. So 2n plus 1 is any odd number. Now the question asks us to prove that when we square the odd number and divide it by 4, the remainder is 1. So let's go and do this. So let's go and square our odd number and divide it by 4. So here's my odd number being squared, and then I'm dividing it by 4. Now 2n plus 1 all squared means 2n plus 1 times 2n plus 1. So just doing claw, 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 I get as a numerator 4n squared plus 4n plus 1 to be divided by 4. And then I'm just going to just sort of finish this off by just choosing to factorize the opening two terms in the numerator to give me this. So we can see that whatever value for n I get, I square it and add n and multiply it by 4. But then what I then have to do in all cases, I then have to add on this 1. I do get a remainder of 1 that needs to be divided by the 4. So always a remainder of 1 still to be divided by 4. Question 13, part A. So to differentiate, we multiply each term by the current power and reduce the power by 1. So x cubed, we multiply by the 3, so 3, and then reduce the power by 1, so 3x squared. Similarly with our second term, multiply by the 2 and reduce the 2 to 1, so we get minus 2x, and then minus 8x becomes minus 8. And the plus 12 disappears. Part B. Now the turning points are the maximum points or the minimum points, and at these turning points the gradient always equals 0. It's flat, so our differential equals 0. So 3x squared minus 2x minus 8 equals 0. So I've factorised this. I've done it the sort of long-winded way rather than by inspection. So I've just split the middle term into 2. So I've said to myself, what two magic numbers multiply to be the 3 times the minus 8, which is minus 24, but at the same time add to be the minus 2, which is 4 and minus 6. So I've split this minus 2x into two terms, minus 6x and plus 4x. I've then fully factorised the opening two terms, that's 3x open brackets, x minus 2 close bracket, and then fully factorised terms 3 and 4, which is plus 4 open bracket, x minus 2 close bracket. Then my final answer comprises the two components which presently aren't in a bracket, so that's the 3x plus 4, and my second bracket comprises the repeated bracket, which is the x minus 2. Now this equals 0, so in turn I've got to consider the value of x, which will make the first bracket 0 and then the second bracket 0. So 3x plus 4 equaling 0, so take away 4, divide by 3, we get x being minus 4 over 3, and the value of x being 2, it would make the second bracket equal to 0. Now for part C, we've just got to think about this a bit. Show that the x-axis is a tangent to the curve C. So that's going to mean that the x-axis is where the curve actually touches either the maximum or the minimum point. So in order for that to be the case, then we've got to show that either the maximum or the minimum point lies on the x-axis. Now to lie on the x-axis is going to mean that that for one of these x coordinates, the y value has got to equal 0. So we're going something along the corridor, but nothing up or down the stairs. So in turn, I need to check whether either of these x coordinates, when I substitute them back into the original curve, do I get a y value of 0? So I'm going to start off with 2, because that looks like an easier number to work with. So substituting 2 back into the curve, 2 cubed minus 2 squared minus 8 lots of 2, add 12, does indeed give me 0. So I know that the coordinate 2, 0 is a turning point. It does lie on the x-axis. So 2, 0 is on the x-axis, has a gradient of 0, so the x-axis is a tangent to the curve C. Question 14. So for part A, I'm being asked to find an estimate for the number of apartments with a value of 80,000 euros or less. So I'm taking my 80,000 euros, going up, hitting the curve, taking a reading, and I'm getting about 96 and 97. So the answer scheme allowed anything between 96 to 98. Part B, on the grid opposite, draw a cumulative frequency diagram for this information here. So we just have to plot the points 20, 0, 40, 15, 60, 44, and so on, and then just join those with a gentle curve. Now for part C, I'm being asked to find an estimate for the increase in the median value for the apartments from 2015 to 2018. So we need to work out the median value in each of those years and see what the difference is, see what the increase is. So in 2015, so the median's the middle apartment. We've got 120 apartments, so it's the 60th apartment, and I get a reading of about 55 for 2015. And I get a reading of about 69 for 2018. So the difference is 69, take away 55, which is 14. Mark scheme allowed anything between 13 to 15. 15 part A. So each of these components in turn has to be thought of to the power of 4. So 3 to the power of 4 is 81, 3 times 3 times 3 times 3. Now, x squared all to the power of 4. When we've got a power inside the bracket and outside the bracket, you multiply these together, so that's x to the power of 8, and similarly y to the power of 20. Now for part B, I've got 3 components to multiply together, the 4n, the n minus 3, and the n plus 5. Doesn't matter which order you do these in. I'm going to leave the 4n alone for now and kick off by doing n minus 3 multiplied by n plus 5. So that's n times n being n squared, n times plus 5 being 5n, minus 3 times n being minus 3n, and minus 3 times plus 5 being minus 15. I've then gathered up the like terms in the middle to get n squared plus 2n minus 15. And then I've gone and multiplied each of these three terms in the bracket in turn by the 4n. So 4n times n squared is 4n cubed, 4n times plus 2n is plus 8n squared, and 4n times minus 15 is minus 60n. Now part C, you've just got to note that this is a difference between two squares. So 4c squared, it breaks down to being 2c, because 2c times 2c is 4c squared. And to get a minus 9d squared, we're going to need to have a plus 3d and a minus 3d. You multiply those together, you get your minus 9d squared. And what actually happens is that the clause 2 and 3 cancel out. So 2c times 2c is your 4c squared. 2c times minus 3d is minus 6cd, but plus 3d times 2c is plus 6cd, so those terms 2 and 3 cancel out. Then our fourth clause, 3d times minus 3d is our minus 9d squared. Now part D, let's start off by fully factorising the numerator. So what two magic numbers multiply to be 12 but add to be minus 7? That's minus 3 and minus 4. So x minus 3, x minus 4. And then if we just take out the x from the denominator, we get x multiplied by 4 minus x. Now as things stand, we can't cancel out any of the terms in the numerator and the denominator. But what we can see is this term here is just the same as this term here once you've multiplied it by minus 1. So if we basically just sort of change the sign of the x and change both the signs inside the bracket, we're left with the same thing. So doing so, we get this, and then the x minus 4 do indeed cancel out. So we're left with x minus 3 over minus x, or if you like, multiplying top and bottom by minus 1, we get 3 minus x all over x. Question 16 part A, work out the probability that they each take a yellow bead. So the chances of Lucy taking a yellow bead are 2 out of 12, but then given that she keeps it, the chances of Julian getting a yellow bead is 1, because only one yellow's left, but we're now out of 11, not out of 12. So it's 2 over 12 multiplied by 1 over 11, top times top, bottom times bottom, we get 2 over 132. You can simplify it if you want to, and you would get 1 over 66. Part B. Now, work out the probability that the beads they take are not the same colour. So you could work through all the various combinations to get different colours, but a quicker way is to just work out what we don't want. So what we don't want are where they are the same colour. So let's go and work out the probability of a yellow and a yellow, a red and a red, and a green and a green. They're the three we don't want, so let's just go and add those up and take that away from a whole to get our answer. So what's the probability of a yellow followed by a yellow? Well, we've just worked that out already. That's 2 over 132. Now what's the probability of a red and then another red? Well, a red with your first pick is going to be 7 out of 12, but then with your second pick would be 6 out of 11. So 7 over 12 times 6 over 11, top, top, bottom, bottom, that's 42 over 132. And then thirdly, what's the probability of a green and then another green? Well, that's going to be 3 out of 12 multiplied by 2 over 11, which is 6 over 132. So we've got a common denominator here, so we can just add up the numerators to get 50 over 132. So it's a whole take away 50 over 132. Well, remember a whole is just 132 over 132. So 132 take away 50 is 82 over 132. or if you choose to simplify it, 41 over 66. 17 part A. So the total surface area of the cylinder is k pi. Find an expression for k in terms of r. Okay, so we're talking about the surface area of the cylinder here. Now, the total surface area of the cylinder is going to be the circle at the top, which is pi r squared, plus the circle at the bottom, which is another pi r squared, and then the curved surface area of the cylinder. Well, from the formula at the front, we can see that's 2 pi r h, but our h on this occasion is 2r. So that's 2 pi r times 2r. And what does this total surface area equal? It equals k times pi. So 2 pi r times 2r is 4 pi r squared. So we've got pi r squared plus 4 pi r squared equaling k pi. Gathering up our left hand side, we get 6 pi r squared equaling k pi. Cancel out the pi's, we're left with 6r squared equaling k. So k equals 6r squared. Now for part B, we're being asked to show that the ratio of the total surface areas is the same as the ratio of the volumes. So we're just going to have to work out both of these ratios and see that they're the same. So let's start off with the ratio of the total surface areas. Well, the total surface area of the cylinder was k times pi, and we worked out that k was 6r squared. So that's 6r squared times pi, or 6 pi r squared. Now the surface area of a sphere, straight from the formulas, is 4 pi r squared. So that's the ratio of the cylinder to the sphere surface areas, total surface areas. Divide through by pi and divide through by r squared. We're left with the ratio of 6 to 4, which simplifies to 3 to 2. So our surface area ratio is 3 to 2. Now moving on to the volume ratio. The volume of a cylinder is pi r squared h, but our h is 2r, so that's pi r squared times 2r, which is 2 pi r cubed. Now the volume of a sphere is 4 over 3 pi r cubed. So if we then divide through by pi and divide through by r cubed, we're left with the ratio of 2 to 4 over 3. Now multiply each of these by 1.5, we get the ratio of 3 to 2. So both our ratios are 3 to 2, so we've shown that both the ratios are the same. Question 18. So the key learning point here, when you want to rationalise a surd and you've got these two terms in the denominator, you've got to remember to choose to start off by multiplying top and bottom by the denominator, but with the change of sign. So we're going to multiply top and bottom by root 8 plus 2. So root 8 times root 8 is 8, and root 8 times plus 2 is 2 lots of root 8. Now with the denominator, root 8 times root 8 is 8, root 8 times 2 is 2 root 8, minus 2 times root 8 is minus 2 root 8, and minus 2 times plus 2 is minus 4. Now because we've had this change of sign, these two middle terms will always cancel out in the denominator, leaving us with 8 take away 4, which is 4. So we've got 8 plus 2 root 8s all over 4. Now root 8 can be simplified itself. That's just root 4 times root 2, which is 2 root 2. So that root 8 is replaced by 2 root 2, and then multiply the 2 root 2 by the 2. We get 8 plus 4 root 2 all over 4. Both of these terms in the numerator can be divided by the 4, giving us 2 plus root 2 as our final answer. Question 19. So, good question this, I think. So it doesn't really particularly matter which order you do these in, but I might as well do the order that I've done. So the first thing I've noticed is because we've got a parallel line AB to ED, that we can say that this angle DEB also equals 73 degrees. It's the Z angle rule. It's the alternate angles are equal. Now, going back to noting that this is a tangent to the circle, the alternate segment theorem tells us that this angle ECB is also 73 degrees. So that's just one of the circle theories we have to learn. Now, the next bit, looking at the cyclic quad DCBE, opposite angles in a cyclic quad total 180. So this angle DCB must be 180 take away 73, which is 107 degrees. So that's this black point here. So if this total angle is 107, of which this part of it is 73, this angle DCE must be 107 take away 73, which is 34 degrees. So, question 20. Now, we're not giving any lengths here, but we know it's a cube, so most of the lengths are all the same, and we're told that GM is the midpoint. So what I'm going to choose to do is just let the total length be 2, so that when we have a midpoint, the length is 1. Now, I think half the battle here is understanding what angle they're asking us to work out in the end. Find the size of the angle between the line MA and the plane ABCD. So you've just got to think about the straight line going from A to M, then dropping down a perpendicular straight down to where it would hit the base, and then back to A. So just going immediately below M, so halfway along from B to C, I'm calling point N. So just hooking out the two-dimensional shape M to A to N, that's the angle theta that I need to work out. So that's my goal, to work that out. That's the size of the angle between MA and the plane ABCD. So this is the angle I need to work out. Now I know that the length from M to N is 2, so I'm going to need to work out what the length from A to N is. So I'm now just going to consider the two-dimensional triangle going from A to N to B, where the angle ABN is the right angle. So A to N to B, well I know that A to B is 2 and B to N is 1, because N's halfway along. So AN squared is going to be 2 squared plus 1 squared equaling 5, so the length AN is the square root of 5. So I've got two sides now, so I can now work out my angle. So I've got my opposite and my adjacent side, so tan theta equals my opposite of 2 divided by my adjacent of root 5. Inverse tanning both sides, I get theta equals the inverse tan of 2 over root 5. Popping that into my calculator, I get 41.81 ... which is 41.8 degrees to 1 decimal place. Question 21. Now I'm told that x equals y minus 1. So this side is y minus 1. This is obviously y. So really, if I now use the cosine rule, because I've got a side trapped angle side, I'm basically creating an equation where y is my only unknown. So I've labelled it up. My angle is my uppercase A, so my side A, lowercase a, is my y minus 1. The b and the c don't matter, so let's let b be the 5 and c be the y. So substituting into the cosine rule, I get a squared, which is y minus 1 all squared, equaling b squared, so 5 squared, plus c squared, so plus y squared, minus 2 times b, which is 5, times c, which is y, times cos of a, which is cos of 60. Now cos of 60 is a half. So I've got y minus 1 all squared, which is y minus 1 times y minus 1, which is y squared minus 2y plus 1, equaling 5 squared, which is 25, plus my y squared, and minus 2 times 5 times y times a half is minus 5y. Now my y squareds cancel, and then if I add 5y to both sides and take away 1 from both sides, I get 3y equaling 24, so y equals 8. So this length here is 8, and this length here being 8 minus 1 is 7. So my perimeter, k, is 5 plus 8 plus 7, which is 20. Question 22. Now this question is fine if you appreciate a regular hexagon is a whole bunch of equilateral triangles. So it breaks down into all of these equilateral triangles. Now the length from A to B is vector A. So we've got an A here, we've got an A here, an A here, and an A here. Now the vector going diagonally downwards from B to C is a vector B. So that's the B. Going from F to E would be a B. But going from D to the origin would be a minus B. We're going up it the wrong way. And similarly going from C to B would be a minus B. We're going up it the wrong way. Now how am I going to get from E to X? I'm going to follow this green trail. So I'm going to go from E to D, D to O, O to C, C to B, and B to X. So that's an A minus B plus A minus B plus A. Gather up my like terms. I've got 3A. Gather up my like terms with B's, minus 2B. So a final answer, 3A minus 2B. 23 part A. So we need to work out the inverse function for f. So we start off by just setting y being equal to the function, and then we need to go through the process to change the subjects. So multiply both sides by x, and then to undo the square root we're going to square both sides. So xy becomes x squared y squared, and we've lost the square root on the right hand side. Now we want all our terms with x on the one side, all our terms without the x on the other, so we're going to choose to take away x squared from both sides. I can then fully factorize taking out my x squared, so x squared y squared minus 1 equals k squared, then dividing through by the y squared minus 1, I get x squared equaling k squared over y squared minus 1, square rooting both sides, I get this. So my inverse function for x is the square root of k squared all over x squared minus 1. Remember, y was just something artificially I introduced to allow me to change the subject. My inverse function incorporates x. Now I've got to find the value of p such that this inverse function equals k. So what value of p when I substitute it in gives me k. So I've got the square root of k squared all over p squared minus 1, because I've substituted p in as my x value, and that's got to equal k. So I'm going to then choose to square both sides to undo the square root. So I've got k squared all over p squared minus 1 equaling k squared. Now in order for this to be true, I need this denominator to equal 1. Because when this is 1, k squared will equal k squared. So I need p squared minus 1 to equal 1. So I then choose to add 1 to both sides, square root, I get p equaling the square root of 2. Now part B, I'm given that gf of a equals k. So I'm going to substitute a into the f function, and then substitute that output into the g function and set this equal to k. So first of all pop a into the f function. So f of a equals the square root of a squared plus k squared all over a, and then I take this f of a and I substitute this into the g function, and all the g functions does is square this. So I've got all of this being squared. Now I'm then attaching the squaring to both the numerator and the denominator. Attaching it to the numerator, it just undoes this square root. So I'm left with a squared plus k squared, and then attaching the squaring to the denominator, I get my a squared. So, and then I've got to set this g f of a to being equal to k. So here it is, equaling k. So I choose to multiply both sides by a squared, which I've done here. I want all my terms with a squared on the one side, so I'm taking away, so the easiest way to do this was just to take this over to the other side. So I've subtracted a squared from both sides, giving me a squared k minus a squared equals k squared. I can then fully factorize, taking out my a squared, and then I can divide through by my k minus 1, so I've got a squared equaling k squared all over k minus 1. Square root both sides, I get a equaling the square root of k squared over k minus 1, and then attaching the square root to both the numerator and the denominator, I get a final answer of a equaling k all over the square root of k minus 1.